Chapter 4, Quadrilaterals and Other Polygons, Section 4.1, Angles of Polygons. In the last unit, we saw that the interior angle sum of a triangle is 180 degrees. Does that apply to other figures? No, it doesn't. We're going to see how we can figure out what the interior angle sum is based on a nice, easy theorem. Quick reminder, it'll be in your best interest to refresh yourself on the names of these figures because how many sides is quite important. Our first theorem is the polygon interior angles theorem that states that the sum of the interior angles of a convex polygon can be found by the formula n minus 2 times 180. What the heck does that mean? N represents the number of sides of the polygon. Now let's see if that works. Remember, a triangle, the interior angle sum was 180. How many sides does a triangle have? 3. So if I plug that in here for n, what's 3 minus 2? 1. What's 1 times 180? 180. Seems to work. Let's try it out. Find the sum of the interior angles of a convex hexagon. How many sides does a hexagon have? 6. So the interior angle sum will be n, where n is number of sides, so 6, minus 2 times 180. Well, first you just need to subtract 6 minus 2, which is 4, and then multiply by 180, and the interior angle sum is going to be 720 degrees. What about the interior angle sum of a dodecagon? Well, that's 12 sides. So number of sides minus 2 times 180. 12 minus 2 is 10 times 180. So that'll be 1,800 degrees. Example 3. The sum of the measures of the interior angles of a convex polygon is 1260. Classify the polygon by the number of sides. Okay, well, this time we're not trying to figure out what the angle sum is. We already know that the sum is 1260. Well, what does that mean? That was the answer to the number of sides minus 2 times 180. So again, number of sides minus 2 times 180 will give you the sum. Well, we already have the sum. Okay, well, let's solve this for the number of sides n. Okay, n minus 2 times 180. How do you cancel out times 180? Divide both sides by 180. And you'll notice that every time you solve this equation, you're pretty much going to be doing the same thing. So that's going to cancel out here, and you'll be left with n minus 2 equals 7. Add 2 to both sides, and we get n equals 9. It's a 9-sided figure, which is a nonagon. A nonagon has an interior sum of 1260. Example 4. The sum of the measures of the interior angles of a convex polygon is 1620, classified by the number of sides. Same thing. That 1620 they gave us is the answer to number of sides minus 2 times 180. So once again, to solve this, number of sides minus 2 times 180. What cancels out multiplication? Division. So all you need to do is start off by dividing both sides by 180. And you'll get n minus 2 equals 9. Add 2 to both sides, and the number of sides of that shape is 11, so that is a endecagon. Find the value of x in the diagram below. Okay, this is a 4-sided figure. X is an angle on the inside of a 4-sided figure. So those angles have to add up to something. So before we set up an equation, we first need to figure out what do those angles add up to. Well, it's got 4 sides. Four minus 2 is 2. And 2 times 180 is 360. It might be in your best interest to memorize that result. A quadrilateral, the interior angle sum is 360 because we're going to be dealing with quadrilaterals quite a lot in this unit. Okay, so we did all that work just to figure out what those 4 angles should add up to. So I'm going to use that 360 and say, well, the interior angle sum, meaning when I add all the angles together, order doesn't matter. it has to add up to 360. Because it's a four-sided figure, the interior angle sum is 360. So all we need to do is combine our like terms on the left, and we get x plus 318 equals 360. And then last step, subtract 360 from both sides. We get x is 42. Use the diagram below to find the measure of angle K and measure of angle L. Well, immediately I notice that K and L each have one arc mark. That indicates that they are congruent. They're the same measure. So even though I don't know how many degrees either of them are, I'm allowed to use the same variable for both because those arcs indicate that they are congruent. Okay, these are interior angles of a polygon. They're going to add up to something. I first need to figure out what are they going to add up to. Because again, I know I have the x, I have the other x, and then I have all those other angles. I have, and the order doesn't matter, 68, 105, 109. I know they're going to add up to something, but I need to figure out what to put on the right-hand side of that equal sign. Well, how can we do that? It's number of sides minus 2 times 180. And again, if you're having trouble counting the sides, you could also count the angles because the number of angles in the interior will always equal the number of sides. So we've got 1, 2, 3, 4, 5, so it's 5 sides. So 5 minus 2 times 180 will tell us what that angle sum should add up to. 5 minus 2 is 3. 3 times 180 is 540. So those angles should add up to 540 because that's the interior angle sum of a five-sided figure, which is a pentagon. Okay, so the first thing I need to do now in solving this equation is look on the left and combine my like terms. I've got an x and an x, which is 2x. I've got 68, 105, and 109, which is 282. Subtract both sides by 282, and you'll get 2x equals 258. Divide both sides by 2, and you get x equals 129, which, let's just double check, is that what the directions asked? It asked for K and L, and we represented by x, so there we go. That is our answer for the measure of angle K and the measure of angle L. It is 129 degrees. Okay, those are angles on the inside of a polygon. What if we make exterior angles by extending the line segments a little bit? So in this diagram, I've got a five-sided figure, and I've made exterior angles by extending the sides a little bit. Well, it turns out there is no formula. The angles on the outside, the exterior angles in a polygon, will always add up to 360 degrees. Always. It will always be 360. Doesn't matter how many sides the figure has. If it's got 3, 4, 5, 6, 7, doesn't matter. Exterior angles will always be 360. Interior, number sides minus 2 times 180. Exterior, always 360. Find the value of x. Well, x is an exterior angle, and I know that the exterior angles in any figure will always add up to 360. And again, it doesn't matter if you do a different order here. You could do x plus 2x plus 89 plus 85. It really doesn't matter, as long as you put all the exterior angles on the left of the equal sign and 360 on the right. Combining your like terms on the left, I have x and 2x, which would give me 3x. I've got 89 and 85, which if I add them together will give me 174. Subtract from both sides by 174. We'll get 3x equals 186. Divide by 3, and you'll get x equals 62. Now, let's talk about the relationship between an interior angle and an exterior angle located at each vertex. At each vertex, the interior angle and adjacent exterior angle form a linear pair, which means in this diagram, angle 1 plus angle 2 has to equal 180. So why is that important? Because we can use that idea to figure out angle measures of regular polygons. A quick reminder, a regular polygon is both equilateral and equiangular, meaning every single angle on the inside will be equal and every single angle on the exterior will be equal as well. So, to find the measure of each single exterior angle, so if you know, hey, this is a regular polygon, how can I figure out how many degrees is each angle on the exterior? It's just 360 divided by n, where once again, n is the number of sides of that figure. So again, n is the number of sides. For example, if it's a triangle has 3 sides, you do 360 divided by 3, and hey, every exterior angle in a regular triangle will be 120 degrees. How do you find the measure of each interior angle of a regular polygon? Well, remember, every interior and exterior angle form a linear pair, so all you need to do, hey, that's 180, is take 180 and subtract your answer above. So you take the measure of the exterior angle and you subtract it from 180, and then you know how many degrees each single interior angle will be in a regular polygon. Let's try this out. Find the measure of each interior and each exterior angle of the indicated regular polygon. Okay, well, we can do that. A regular pentagon has how many sides? 5 sides. So let's start off with the exterior angles. Each single exterior angle will be 360 divided by the number of sides. So all you need to do is do 360 divided by 5, and that you get that each exterior angle has a measure of 72 degrees. So that is the measure of each exterior angle. How do you get the measure of each interior angle? Well, we take that answer, and all you do is subtract it from 180. And you get that the measure of each interior angle is 108 degrees. What about a nonagon? Well, the measure of each exterior angle will be 360 divided by the number of sides. Well, a nonagon has 9 sides, so I'm going to do 360 divided by 9, and get that 40 degrees will be the measure of each exterior angle in a regular nonagon. Again, every single outside angle on a regular nonagon will be 40 degrees, 40 degrees, 40 degrees. What about the interior angles? Every single interior angle will be 180 minus 40. So every single interior angle in a regular nonagon will be 140 degrees. Example 9. A trampoline is shaped like a regular dodecagon. Find A, the measure of each exterior angle, and B, the measure of each interior angle. Okay, well, this is pretty much the same thing as the last problem. So if it's a regular dodecagon, a dodecagon has 12 sides. So all I need to do to figure out the measure of each exterior angle is divide 360 by the number of sides. So every single exterior angle will be 30 degrees. And the interior angle is going to be nothing more than 180 minus that result, meaning every single interior angle on the inside of that trampoline will be 150 degrees.